Good afternoon, and today we're actually back with one of the 3v22s. So the 3v22s last time seemed to exhibit almost exactly the same issue as the 3v16. They have a simpler servo circuit, so given that I haven't adjusted anything on the servo circuit, I'm going to start focusing on the supply of power to the servo circuit, which in retrospect is probably where I should have started when looking at the 3v16, or the JVC as it is also known. So what we're probably going to do is we've got a number of capacitors. We have this large 3300 microfarad device, 35 volt. We've got a selection of 3300 microfarad caps. We've also got a series of smaller electrolytic capacitors as well. What look like, I think, Zener diodes and some ceramic, I think they're ceramic capacitors, and a series of resistors. So from what I've experienced, the general weak points seem to be the electrolytics. As you can probably see, these ones have already got, you can see a bit of corrosion on the leg. So it looks like they are probably potentially on their way out anyway. So let's see what the tester brings up for each one as we remove it. I don't know if it will give us really sort of fantastic results, given that that tester doesn't seem to be 100% accurate, but it does seem to be accurate enough. So what's this large one here? This one is 220 microfarads at 63 volts. I do have those, so that's good. So we may as well start off with the biggest, and that will be our 3300. So negative terminal, so plus is there, that's positive, negative is there. So let's pop this one out. So that's one, that's come up quite cleanly, and two. That's also quite clean as well, actually. So that's come away surprisingly well, actually. Not bad at all. So get rid of some of that. Nice clean removal. So let's see what that measures out at. I've noticed that the bigger ones don't seem to be as affected as the smaller ones, but it would be interesting to see what we get. So I'm going to go with opposite ends. So I'll put red on plus, green onto negative. You can actually see which one's positive. It's got a plus and minus there. And the minus corresponds with this side, which is what you would expect. So let's see if that works. And that's registering 4075 microfarads, ESR 2.1 ohms, and a V loss of 1.6%. So if we compare that to one of the new ones that we're going to be putting on, so here's a new one, and you can see that they are the same value, albeit it seems that capacitor technology has moved on. So we'll go for green on negative, so that's the shorter leg, and positive we will put red. So let's put that across the measure. And that one is coming up at 3585 microfarads, V loss 1.9%, ESR 27%. I'm not sure if that's worse or better. V loss 1.9%. I'm sure that's worse. Let's try this again. Same value. Let's try it with the yellow. See if that makes a difference. No, the same. Let's replace it anyway, because this is brand new. So, positive will be the longer leg, negative is the red dot. So, that's in. There we go. Let's grab some solder. I haven't got solder to hand. Let's go and fetch some solder. Right, here we are. Let's blob a bit of solder onto here. That's that one, and that's that one. There we go. Right, let's grab some snips. There we go, and there we go. So, that's those two taken off. Oh, one thing I've got to mention, before I started diving into this board, I took plenty of photos of all of these connectors and which leads plug into them. So when I come to reassemble, it shouldn't be too much of a problem. We've got a selection of these bridge rectifiers here. This one's got a heatsink. This Matsushita, that looks like I would guess that is a little transformer. Oh no, RY1, sorry, that is a relay. So that is a relay. It looks like this would be potentially, actually not sure, I wonder if that's a connector on a different version of this board. Right, let's go to our next biggest cap, which is the 220 63 volts, and that is C12. Positive side there. So let's get that started. There we go, that's nice and clean. Let's pull that one out. That one is a little bit stuck on there. Oh yeah, you can see why there's a little bit of solder on there. So what we should be able to do is nudge it through like so. And a little tug. May need to put a little bit of a sucker on there as well. I'll just place this under here so it's got something to rest against. And there we go. Oh, that's actually been enough to bring it through. And there's this capacitor. Doesn't actually look too bad underneath. Let's see what it measures out at. So, positive is not this leg, positive is this leg. Let's see what it comes out at. So that one's coming out at 220 microfarads, V loss of 0.9%, ESR 0.39 ohms. Let's try one of these new ones. So negative is this leg, positive is this leg. measuring quite similar actually, so we may as well place the new one on. There's no harm in doing that. Right, this was fun last time because you got this sticky material which seems to cover the legs. So what I did last time was peeled it off like so, gradually peeled back the sticky material and gently does it. One leg, two legs, and that brought it back through. So what I should now be able to do with our longer leg as positive, remembering that positive is this side, and we can see negative because we've got the dot there, is to go through with positive and negative. There we go, and loop it over, get the solder, blob of solder onto there, one, and two. There we go. So, a couple of snips. This one. And there's the other. There we go, there's that one. And there's that one. Right, so next one I think we have is, I think we've got to start on the smaller one. So let's go with C05, 100 microfarads at 25 volts. I've got 100 at 35, that should do. C05, positive towards that side. It seems the smaller ones that usually give the problems, to be honest with you, so I'm hoping that replacing these smaller ones will actually yield some positive results. So, let's see what will happen if I do this. There we go. I think that's coming free. Very gently does it. There we go, and whoa, it's my soldering iron stuck in its holder. I'll get that out in a minute. There's that coming through, and that should be coming through as well. And there you go, that's through. Bit of corrosion on the legs. Be interested to see what this one comes up at. So positive is here, negative this one, tester is flagging unknown or damaged part. That might be why, because that came off. Let's try it again. (109) VLOS 0.8, ESR 0.5. Let's try a new one. So that will be 100 microfarads, 35 volts this time. So positive and negative. There we are. Not sure if that's less or not. I can't remember. That's the value it's given. Oh well, may as well replace it. Once we're here, so positive is this side. You can actually tell because we've got the dot there for negative. So positive and negative, in we go. There we are. And solder. Yeah, need to remember how to get this out. So that's stuck in one of the holes. It's actually really annoying. It's really got itself stuck, as you can see. So when it does that, do that, and out it comes. There's no need to panic. And okay, in we go. There we go. There we go. Right. I'll chop all the legs after I've finished, actually. Just give me more time. Right, next one is... what's this? 3.3 microfarads. Really? 3.3 at 10 volts. Or is that 33? Ah, 33. Yeah, that looks like 33. Okay, let's get that one out. That is C06 positive that way. C06, in we go. 1, 2. C06 comes straight out. So let's take a look at this one. This one is 33 microfarads. We do have a 33. There we are, 33. So positive leg is that way. So you can actually see again, we have the little dots to show us the way. There we go. So 33. Let's go in. There we go. And this one. There we go. Right. Next one is this one. This one is 47. We have a 47. Positive, that is C08. And C08 positive is towards the top. C08, in we go. That wasn't perfect. That was better. Let's try that again. That's a bit stuck by the looks of it. So there. Let's try it again. Okay. Here, down, there. Okay. Here, down, there. Right, hopefully that's done it. Yeah, that's closer than it was, a lot closer actually. So let's see. Poke that through. There we are. Oh, there it is. Oh, that's one of the ones that's got corrosion on the legs. Let's see what that comes up with measurement wise. So, positive leg is this one. Negative leg is this one. So it's 47. Comes up as 50 with 1.8% and 0.70 ohms. 47 at 25 volts. Let's try that. So positive leg is the longer. There. Oh goodness. Yeah. There we go. Negative leg. Here. There we are. See what that measures out at. Honestly, not sure if these are better or not, to be honest with you. Let's go into there. So that's positive there, negative there. Again, you can see with the dot. And that one is 25 volts, 47 ohms. And we should be able to verify that with the one that we were just measuring. That's the 33. 47, yep. Right, in we go. There. And here. There we go. I think we have one more, which is C09. C09 is 100 microfarads. We do have 100. Positive there. So let's get that one out. There we are. There we go. Right, that one is ready to come out. At least I hope it is. Let's try that again. There we are. That should be good to go. And yeah, I think that's out. Yeah. Okay. 100 at 16. Right, 100 at 16. This one will do. Right, positive there, so positive, negative, you can see that, we've got the legs. There we go, that's in, that's that one. Might help if I use the solder rather than the solder sucker. There we go, and there we go. Right, let's chop some legs off. There we go. Right. That's been recapped. So I think the next thing I need to do is fit this back into the machine and make sure that the machine still powers up. Right, let's get that back in. Right, I've got the power supply board, distribution board back in. Just going to grab some power. So I've got power cable coming over now. Make sure that it is switched off, which it is. In with the power on. Clock is illuminated. Don't seem to have. Let's put it out of standby. So it's out of standby. Video lamp is on. As you can see there, yep, video lamp is on. Yep, it's doing all of the good stuff that needs to do. Let's get some measurements off the supply itself. So, going by what we learnt from the 3V16, let's see what we can find off of, first off, this large connector. So let's try pin 65. So nothing there, there, there. There might be something off one of these test points. Nothing off the test point. So let's try 11. So we've got 6. Is that 6.3? Hang on, let's go back to the 20 volt section. 6.3, 6.4, 15 volts. 15 volts. Smaller connectors down here. 5. Nothing. Nothing. 5. Nearly 12. Nearly 12. Nothing. 12, 11.5. There we go. Another test point. 19 off of that test point. What's this? That's not a test point. That's a resistor. 6 off the foot of, so 6 volts off the, around 6 volts off the foot of this potentiometer. I'm not sure if that's like a 12 volt supply like it was in the 3V16. Test point 1, about 12-ish volts. So I'm not going to adjust that potentiometer at all, because I'll be honest, I'm not sure what value it should be, but we do seem to be getting around 12 volts out of that particular board, give or take. Actually, let's measure it again. So, test point 1 gives us about 11.8. Test point 2 doesn't give us anything. So off the big capacitor we get 19 volts. So that's 19 volts going in. Another connector, so 12, 12, nothing, nothing, 12. So at a wild guess, I'm saying that that board should be putting at around 12 volts, give or take. Right, let's power this off and let's pause this. Sorry, I paused it just as I was about to finish what I was saying. Pause the video, grab from my 3V16 JVC HR 3660 that I've parked for the moment, grab the belts off that, fit the belts to this deck, and once we've done that, let's see where we are. There we go. So what I've done is I've borrowed the belts from the JVC and I'm placing them into the Ferguson. So this is basically the 3V22 borrowing the belts from the 3V16. Now this mechanism is actually different to the one in the JVC. It's later, I think, because we've got these friction wheels instead of a selection of long belts. So you would have these sort of long belts running between, I think, this one and up there. But in this deck, it seems to be using these friction wheels. The last time I was in here, I did actually replace, well not replace, I did actually put some rubber renew over the idlers. I also put this firmly down as well because it was above the point where the pickup would actually work. And that's when obviously I tested and noted that we had a load of capstan sink issues. So obviously based on the experience that I had with the JVC, I decided to repair this one. See, look at that. So that motor is actually being energised by me spinning this motor. To actually energise it, there's enough drive in that motor to actually energise this one. Let's see if it does it now. It does do it slightly. It's almost like there's a feedback loop between this and this, which wouldn't surprise me. So there is this capacitor here, which is a 1 microfarad 50 volt capacitor, and I was tempted to replace it. Now it's covered in this sort of shielding material, so what I'm thinking of doing is I've got a 1 microfarad 50 volt cap here. The reason why I want to replace it is I have read that this can cause problems with the feed to the motor, so it isn't as smooth a feed as it should be. It can cause problems with the head speed. So I'm interested to see if, let's get rid of this one. So that's one leg. That'll be our positive leg that we've just removed. And what we're going to do is chop a little bit off of this. Or at least try. So we'll put that on there. So we should have a little bit of leg exposed, like so. We're going to get the new capacitor, so that's going to be positive going into there. Mount it like this, and what I'm going to do is blob the solder at the top so that I don't have to unsolder it from the base where there is quite a lot of other things going on which I don't really want to disturb. So let's grab my soldering iron, which I put all the way over here. It's still nice and warm, and we are going to remove this belt so we don't hit it with the solder. Ring on, apply a little bit of heat to there and melt the leg thing. That was useful. Not the desired effect, but totally predictable, to be honest with you. Let's try that again. Actually, it has made that shorter, which is quite useful. So sleeve up the leg like so. Go in with our positive there. Remembering that there, although this is an Elner capacitor, so I don't think they're actually too bad. Going underneath, like so, and I've actually just thought, why am I doing it like that? Because I've still got too much on these legs anyway. So if I'm going to do this, I would need to, let's have a think. Let's chop this off again. So this one can come off. That should do it. There we go. Let's remove that. So let's actually chop this down. So we're going to have a little bit off positive, a little bit off negative. That's going to leave us with a much shorter leg arrangement. So let's try and sort out the positive one first. So positive leg here. And we need a way to clamp this in place. I've actually just thought of the ideal thing to do that, which is the testing leg thing from the test capacitor tester. And in you go, like so. So that's the negative leg. Positive leg, in you go, there. Right. Probably destroy the tester now, but, or the tester leg rather. Let's try and keep the heat over to one side. There. And done. That actually worked. I'm actually quite surprised. That actually worked quite nicely. That's actually fused two of those together. Let's start with the, let's go over to this negative leg here. And go in, there's a blob already on the soldering iron, so blob it together like so. And there we are. That capacitor is now attached. So I'll actually put it out the way like so. And because none of it is touching, we should be okay to dispense of the sheath. Normally I would say make sure that you put the sheath back on, but in this instance we're going to do without it, and thankfully we haven't killed that too much. Right, let's put the belt back in, or on rather, there we go, around there, like so. Spin that so it actually settles a bit, because that's a bit that's riding up at the moment. That's better. Okay, let's fire her up. So go back in and down like so. Making sure that, yep, that is nicely out of the way. And we haven't had to disturb any of the other capacitors that are on there, which is perfect. That is like that, that's like that. That needs to come across, so there we go. And let's bolt or screw this down. So we'll start with this central one first. Move on to this one. Go. That's in. Do that one next. So we've got all three of them this time. Right. Let's put the base back on, but not fully. So the base will just go like so for the moment. And we'll come over and down and around, flip it into standby, power on, out of standby, should be good to go. Let's grab an RF cable, pop the RF cable into RF out, and let's fetch a cassette and see how it turns out. Oh, fast forward seems to work, that's something. Let's put the telly on. We haven't got the CRT down here today, so we're just going to use the Bravia. Given my experience and previous experience with the whatchamacallit, the 3V16/HR3660, I don't think this will do anything at all, but I am willing to be pleasantly surprised. But expect disappointment. Let's go to setup. I think we had it set up on channel 2 possibly. Nothing on 2. Got something on 1. Let's hit play and see what we get. I was trying to play. There we are. That seems more like a belt slippage than anything, rather than anything else. No playback signal at the minute. Let's see if we can tune this in. Let's see what's slipping. So it's not slipping on the top belt. It's probably going to be those pulleys, to be honest with you. You can hear it straining slightly, but it is rotating. The pinch roller is pinching. Let's get it tuned in. So, analog setup, manual program preset. Let's go up to 36. Let's get the test signal in play. Go that down. So back down. 40, 39, 38, 37, 36. So we've got something on 36. Sounds dire. The picture is... Who is the picture? The picture is predictably dreadful. The machine really sounds like it's struggling, to be honest with you. That's the current sound that we have from it. Let's see. See if adjusting this voltage selector will do anything. Well, that has done something. We've now got a picture, amazingly. So, amazingly, astoundingly, we have a picture. However, that's way too fast. Let's get the panel off on the side. So that was by jacking up the voltage a bit. Let's get this panel off on the side. I really don't want to be having to adjust the Capstan Speed again, but you never know, that could be part of the issue. Might also have head issues as well. Let's just... I'm going to mute this because the last time I did this I got a copyright strike. I probably already have a copyright strike now. Let's bring that voltage down a bit. So, still playing. If I lower the voltage down, so not enough. Pop it up a little bit. And we're about there. Tracking doesn't do anything. So Capstan Speed, we've got record level, channel 1 switch phase, preset, switch point, playback level, bias level, E to E level, electronic to electronic in other words, cap sample, so that might be it. Let's see what that does for us. Okay, that does that, all the way to the other way, does that, so that does actually slow it down a bit. So let's put that right on the slowest, and let's jack this power up a little bit, see if we can get a nice balance. So this is the power output from the regulated power supply board, and that is getting closer, definitely. Right, that's maximum now. So that is with Capstan sampling point at minimum, that power output maximum. Let's see what it sounds like. Jack up the Capstan sampling point slightly. That's the head. That's the head speed. Ooh, don't want that. Head drum speed. Let's go back down again. So back down even further, and you get to a point where there's no drum servo lock, so back up a little bit the drum speed. About there. So let's come down again on this power. Let's actually measure the power coming off of one of those points and see if it changes when I adjust that potentiometer. So let's go for, say, test point 2, nothing, test point 1. That's now showing 14 volts. So if I go to test point 1, there, and if I go to the power adjuster, that's at 15. That's dropping down a bit. Let's see if we can get that bang on 12. Whoop, up a little bit. 7, 6, 8. that's too high again. Oh well, back up. What are you settling on? Right, 1183. $11.92. $12. Okay. So we've got 12 volts. We have at the moment a loss of head sink. So we're not going to touch the power supply again because 12 volts seems to be the sensible figure. So head sampling point, which is this one. Turn that a little bit. Head speed is increasing. And okay, that's too fast, and that is coming down nicely. Must be too slow. Right, let's see what the sound is like. Probably ruined, to be honest with you. Let's see if we can do anything with that capstan. So, on the JVC, it's stated that you should have a Capstan Speed set to, what was it, 6 volts. So, if I have a look, I've got a ground point here. I'll actually ground it here. So there is, yep, no voltage on that. If I look, so this is test point 8, it's 4.3 volts, test point 9, 6.5. So Capstan sampling, which is, so that's our head sampling, Capstan sampling. Let's check the legs on that. So at the moment that is 9 volts. That one is 2, that one is 2. So 9 volts is rather high. Let's see. I just hold these two in place, which is really difficult with one hand. So that's those two held in place. I'm going to get my adjuster and I'm going to knock it down. That's a higher. Let's go down, down, that's as low as we can go. Oh no, it isn't. Oh, too low. Up a little bit. 5. I want to get to 6 volts, so up, 5. 5.06, 5.0, 6.2, and down, 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 ever so gently. There's a real fine line between 6.2, 6.1. Just realised I was touching completely the wrong bloody thing. Our capstan is still at S0 on that one. 2, 2, okay. Up to 8, 9, 8, right at 9, back down, 8, 7, that's as low as that one would go. That's actually, is that too fast? That's slower. So that's at 9 on the slowest point. So let's measure the other leg. 2 and 2. What's that preset one I was touching? The preset one. Does that change the voltage at all? Yes, it does. That goes to 0. So if I touch the preset takes us. No, doesn't make any difference to that. Let's set the preset. Actually, let's set the preset that I just touched. So that is measuring 7. Let's get that down to 6. It's too low. 5. 1, 2, 3, 2. Oh. 6.3. Down to 5.4. 6.3. 6.2. 6.1. Oh, such a fine line. Alright, that's probably minute adjustments to get that to 6. That's about as close as I reckon I could get that. Right, capstan. That one measures 9. It's measuring 2. It's measuring something else. I'm going to do about capstan speed. It seems to be all over the place at the minute. So capstan. Okay, capstan. That's 9. And so volts. Right. Let's see what happens if we go down a little bit. So that is slipping off. Okay. It's really tricky to get a good point right there. Now let's go down a bit. It's slipped off. So let's drop down. Oh, come on. That is 7. That's still 8.9, 8.8, 8.6, 8.2. 8.3. 7 point something. Right, that's as low as I can get that. For some reason that's gone back up to 9. That's bizarre. Okay. Not sure what's going on with that. And it's lost. So that's slow, that's fast. So that's down to about, it's on about 9 for some reason. Now, I'm going to try something a little bit different. So I've got that down there. So let's see what the sound is like. The sound is terrible. Let's try knocking down this voltage again. I know I said I wasn't going to touch it, but be interested to see if it gives us more adjustability if it's lower. So that's right down the bottom of that voltage curve. So the head sampling point, where is my head sampling? There. And we have, we're getting a picture again. Yeah, we've got a picture again. Whoa, that's actually quite stable. Don't think it's stable enough though. It's almost there. Let's see what it sounds like. Still a little bit all over the place. Let's try. Let's try that Capstan sampling point again. So I'm going to bring that down gradually. So down to the bottom of the travel, that is quite flickery. And what's the sound like? Very muffled. So let's try going up again. Not going to be long, so just coming up a bit. Not going to be long. So we're going to be finishing this video soon. I'm not really sure where else I can go with this one. As we still seem to be having the same issues. So I've recapped the power supply. I've also replaced that capacitor on the motor, for the sake of argument. Bit of trial and error. Right, so I'm going to try upping that power again. Let's put the power up to maximum. So, you know, I thought I'd try that way. So, bring the head speed down. speed down. Capstan speed. Right, so head speed. That's too high. That's too low. Oh no, hang on. Whoa, I had it almost there. Come on. I think we need to get a service manual for this. I could try twiddling these all day and not get anywhere. That, at the moment, is best I can get. Right. Let's park this. Okay, that's going to be it for today. If you've got any suggestions at all, don't forget to leave a comment, don't forget to hit the like button, don't forget to subscribe, and I'll see you again soon. Thanks for watching.